Hey, hi everybody, and welcome to the final video in the series TensorFlow Basics with Hemant, and that's myself. In the last video, we discussed how to train our model using distributed training. So far we have been able to train our model either it on the single GPU, single machine, or multiple GPUs and multiple machines, right? So in the end, we are ready with the trained model so far, right? Now the topic for this particular video is how we are going to deploy our trained model and how we are going to scale our deployment in the production, right? That is the topic that we are going to discuss in this final video, right? So more specifically, we are going to talk about the TensorFlow serving, which is going to help us deploy our model, and how we can deploy the model with the TensorFlow serving, and how we can access the deployed model, right? So the whole purpose of deploying the model and for that matter training the model is to use for some business use. So for that we need to send a prediction request to the deployed model, and that is what we'll see as to how we can send the prediction request to our deployed model, right? And what are our options for scaling the deployed model? So scaling as in, say for example, initially we might have a few hundreds of requests. Going forward, it can run into thousands, it can run into tens of thousands. So how do we scale our deploying model to take care of all the varying number of incoming requests? So that is one question we will try to answer. And another question is, when we are talking about productionizing the machine learning model, we also need to consider the fault tolerance, right? So say for example, if the model is deployed on two servers, and if one of them fails, how the other one is going to take care of that particular load, how we can fall back to from one machine to another machine. So that is the concept of the fault tolerance that we have. So our objective is basically to have as much uptime as possible for the deployed model, and we'll see what are the different options for achieving that particular objective. Okay, so let's get started with the TensorFlow serving, right? So TensorFlow serving is basically a high performance and a flexible serving system for machine learning models designed for production environment, right? So this API is provided as a part of the TensorFlow itself, and from the picture you can see that there are a couple of components here. So one component is a source component, another is a loader component, third is a dynamic manager, then there is a component which is kind of sitting between the client and our manager, which is hosting the actual model, right? So we'll briefly understand what these different components are. So when we are talking about serving life cycle, which starts when TensorFlow serving identifies a model on the disk, right? So when we train a model and we save it onto a disk, the source component is going to pick up that particular model. That is, it is going to, the source component will understand that the model has been saved onto a disk, and then what it is going to do is actually it is going to create a loader for that specific version of the model, right? And once the loader has been created for that specific version of the model, loader will have a pointer to the model on the disk along with all the necessary metadata. And then once it has created a loader, the source is going to send it to a manager as an aspired version. Okay, So source component is basically related to the source of that model, something like a disk where we are going to save the model. Once the model is saved onto disk, it is going to understand that the model has been saved, and then it is going to create a loader for that version of the model, and then it is going to let the manager, dynamic manager, know of that particular version. And once the manager receives the aspired version, the manager proceeds with the serving process. That is, it is going to get that particular version of the model ready for the serving purpose, right? So what is a serving? So serving is basically responding to the client request, right? So at the end, when the client is going to request the handle, the manager is going to return the handle for that servable or the aspired version which is made ready for the serving process, right? And then after that, we can send the request to the model, and it can respond to those requests, and finally we are going to get the response, which is like the prediction for that incoming request, right? So TensorFlow serving requires models to include one or more signature defs. So there is a default signature def depending on the input data signature, but then we can provide different signature defs also. So these are the different components which are part of the TensorFlow serving, and that is how those different components are related to each other. Okay. Now when we are talking about the TensorFlow serving, there are two options for deploying the TensorFlow serving. So one option is to basically deploy the TensorFlow serving onto a single or multiple servers, or second option is TensorFlow serving is packaged as a Docker container, and we can use that Docker container also. So two options for using the TensorFlow serving. One is to install it as a on a server, and second option is to deploy it as a Docker container. Okay, so when we are talking about the Docker container, what we are going to do is obviously we need to install Docker. Then after that we need to get the TensorFlow serving Docker image which is available and which is made available by the TensorFlow. So we can just use Docker pull command to get that image of the TensorFlow serving. Then once we have the image, actually we can run this particular image, or a container as we call it, and we are going to bind it to specific port onto a server, and we are also going to give a name to the model, right? And what we are also going to do is we are going to specify the source. Okay, so where our model is and where it is going to be copied onto the container. So this is where it is going to be copied. In this particular case, going to be copied onto the container, and this is the path where it existed on the kind of a local storage. Okay, once we run this particular container with a path to our saved model, we can send the client request to it and get the predictions from the deployed container. Okay, now we can also do it on the GPUs, and there's a little bit of a difference in the container that we have to use. So in this particular case, we have to use the NVIDIA Docker container, and then there's a difference between the image of the TensorFlow serving also. So we are going to specify something like latest GPU, but otherwise the run command is going to remain more or less same. Okay, now once our model is deployed, there are two options for us to send the prediction request to the deployed model. One of the options is to use gRPC API. Now gRPC API is like a client server API, and there's a concept of an interface. So interface is like, input output uh, definition, and server is going to implement that particular interface, and on the client side we can use a stub, gRPC stub, and for each language we have different kind of stub, and even though in this particular picture we are showing only Ruby or Android, there are many other languages on which the client for the gRPC are supported. Okay, so that is one way of invoking the deployed model. Okay, the second way is basically to use a RESTful client API. Okay, so in a REST client API, there's a concept of a request and response as a JSON object. So we format the request as a JSON object, and we get the response as a JSON object. And here is an example of the object. So from here, this curly bracket and instances. So instances is basically the data sets, the input data that we are going to provide, and this is the type of the request and where we are sending that. So this is the URL of the deployed model actually, and this is the verb which decides as to what we are expecting that deployed model to do. So in this particular case, we are saying that we wanted to predict what is the outcome based on the input data that we are giving to it, right? So two options for invoking the deployed model: one is the gRPC, second is the REST client API. Okay, now one of the easiest and probably really good way to start and deploy your TensorFlow trained and saved model is basically to use the Vertex AI. So Vertex AI is one of the recent services which is launched by Google Cloud, and that allows us to import the saved TensorFlow model and deploy it to an endpoint, and even auto scale it if required. And it can also allow us to split the traffic between the different versions of the model. So if you have two different versions of the model, we can split the traffic also, so which allows us to kind of do the rollover to the new model. So say for example, if you trained a new model and if you want to roll over to that new model, we can control the amount of the traffic which is going to the new model versus old model. Okay, and we can auto scale it also. That means we can automatically increase the number of server based on the incoming traffic. Okay, and I'll show this the actual console also just in a couple of minutes. But before we do that, let us discuss the other options also for deploying and scaling the TensorFlow deployed models. So first option we saw is the Vertex API, which is like a fully managed option because everything is going to be managed by this Vertex AI service by Google. Second option that we have is to deploy it on any kind of Kubernetes engine, right? So here we are saying it is Google Kubernetes engine, but it holds good for the other Kubernetes engines also, either by AWS or probably Microsoft also. So what we do in that particular case is the TensorFlow serving can be run as a Docker container and deployed and managed by Kubernetes, right? So TensorFlow serving is designed to run on the Kubernetes because TensorFlow serving is a Docker container and Kubernetes can run the Docker containers, right? So what we do here is we deploy the TensorFlow serving as a Kubernetes deploy on Google Cloud Kubernetes engine. Okay, so once it is deployed on the Google Kubernetes engine, what we can do is we can use the features like Kubernetes horizontal pod autoscaler to automatically scale the number of TensorFlow serving replicas based on the observed CPU utilization. So here the Kubernetes pods are going to be auto scaled. So say for example, if you have two servers, the number of pods on those two servers are going to be scaled up or down based on the CPU utilization. And it also supports the cluster autoscaler. That means the cluster autoscaler can automatically resize the cluster's node size also. Okay, so for example, initially let's say we had two servers, it can go up to 3, 4, right? So using both of these, we can essentially deploy the machine learning models onto the Kubernetes, and we can basically scale as we need to. And since we can set up a cluster with multiple servers, we also take care of the fault tolerance as well, right? Third option is a KubeFlow. So KubeFlow is an open source machine learning platform dedicated to making deployments of machine learning workflows on Kubernetes simple, portable, and scalable. Right now, why is it good? Two main things. So first of all, KubeFlow is sitting on top of Kubernetes, right? So it can be essentially deployed on any Kubernetes engine, as we saw earlier. All the different Kubernetes engines which are available, like Google Kubernetes engine, Azure, and AWS Kubernetes engines. Now, good thing is it also provides out-of-the-box interfaces with GCP, AWS, Azure, or you can deploy it on-prem or local. That means if we kind of have some of the models we can run on GCP, some on AWS, or if you want to change from GCP to AWS or AWS to GCP, we can do it easily if we are using the KubeFlow. Second reason for using the KubeFlow is, say for example, if you are using multiple deep learning frameworks, say something like some of your projects might be using PyTorch, some of them may be using TensorFlow, and you could even be using MXNet. So KubeFlow essentially is able to talk to all of these, right? So it is able to accept the trained models from all these deep learning frameworks and then deploy it to whatever cloud platform or even on-prem or a local platform that you want to deploy your model to. Now that's a fantastic thing, right? That means you from the overall landscape point of view, ML landscape point of view in your organization, you are not dependent on any specific platforms, but you're using a single platform which allows you to talk to all sorts of deep learning frameworks and all sorts of cloud platforms. Now that is the value of the KubeFlow. Okay. Now as a part of the KubeFlow, we also have a component which is called as pipelines, and pipelines will allow us to orchestrate the machine learning workflow. So when we say orchestrate, it means that we can have end-to-end machine learning workflow, and end-to-end machine learning workflow could involve data processing, data transformation, data training, and deployment, and so on, right? And then depending on the cloud platform that we are using, say for example, if you're using GCP, your data pre-processing might involve getting the data from the BigQuery, and then you could use the data flow for processing your data and things like that, right? So this particular part, like cloud dependent part, is going to be implemented depending on what components that particular platform provides. But from the overall orchestration perspective, we are going to use the KubeFlow pipeline, right? So now that is fantastic, right? Now, say for example, if you are using AWS, the cloud related components will change, but your orchestration can still remain on your KubeFlow pipeline. So it's a very good way of setting up your machine learning workflows, because you will become pretty much platform independent that way, right? So these are the three kind of main ways: Vertex API, then using the Kubernetes kind of engine, and then using the KubeFlow and the KubeFlow pipeline. These are three really major options for deploying and scaling your machine learning models in the uh, uh, the fault tolerant manner. And before we actually come to the summary of all this, we will also see some of the demonstrations that we have, and then we'll come back to the summary and wrap up this particular session. Okay, so let's get to the some of the notebooks that we have. So the first option, okay, let's set the runtime to GPU. Okay, save. Okay, so what we are going to do in this particular case is we are going to see how the model can be deployed on a server, right? So earlier we talked about two options for deploying our models. One is directly on the server, second is on the Docker container. So this is the first option that we are going to talk about. So let's quickly import some libraries. We have imported libraries, some more libraries here. So these are some of the other dependencies for the Google Colab. We are going to import the data set. So we are using this fashion MNIST data set. So that has been imported, and then we are going to build the model, and we are going to compile, train the model, and finally we are going to save the model. Okay, so our model is trained, and next step is actually to save that model into a model directory. So this is a usual thing, right? Using the Keras API, we can save the model, and we can also check what's there into this particular model. So we can see that the saved model has all these different files. Saved model, so this is the structure of the model, this is the variables, and there's no need to examine the model as such. What we can do is what we need to do is actually now since our model is saved, we need to get the model server, right? And model server, the path of the repository, that is something which we need to set in the operating system tool, apt get. So that's what is going to happen here. So I think I just forgot to execute this, and then we can execute this. Okay, so the path is set here, and then we are going to get this TensorFlow model server. So we got the TensorFlow model server. Now we'll have to run this. Okay, so there are like we are going to have this REST API port, model name, and model base path. So the command here is actually we are going to run this, and we are going to set the REST API port to 8501. Fashion model is the name of the model, and this is a path of the model that we have. And then we are going to tail the server log, and then we need to send some requests, right? And for that we need to some data, so we are going to choose some images randomly for that. And then we need to, since we are going to use the REST API, we need to convert it to the JSON format. So we are going to pick up like 0 to 3 images, so 0, 1, 2, and then we are going to convert it to a list, and like we are going to use this JSON.dump to convert it to a JSON format, and then we will be invoking the REST API. So for invoking, so here we got our data ready, and here what we are going to do is we are going to install this request package, which will allow us to send some requests, like request dot post, and this is the URL to which we are going to send our request, and data is equal to data that we prepared earlier. And then this prediction that we are going to get, that is going to be a number, right? That's a class of the image, and that class of the image is going to be converted back into the image actually. Okay, so that is what this show function is doing, right? So this is what we got actually. So we are basically getting this image of the ankle boot over here, right? So that summarizes as to how we can install a TensorFlow serving onto a server. In this particular case, we installed it onto the Google Colab notebook server itself. Okay. Now the second option that we have is actually we want to basically run it onto the Docker container, right? But for us to run it onto the Docker container, we'll have to take a model and save it in the first place. So since we are using the Google Collaboratory notebook for training our model, what we have to do is actually the saved model that we are going to get actually is going to be stored into the Google Collaboratory notebook server. That we'll have to copy it onto the Google Drive uh, of our own account, and then from there we'll have to download it onto a local hard disk and then deploy it onto the Docker container from there. Okay, so that's what is the purpose of this particular notebook. We are going to basically create a simple model and then save it onto the Google Drive for us. So this is a function which is going to give us the compiled model, and we call that particular function get model to get the model, and then we are training the model, right? So we create this test input, test target, and just remember that this test input is 128 samples of 32 kind of length of 32 length vectors, right? So we have 32 inputs as 128 inputs of 32 each, right? So 32 like a vector of 32 length, and the target is just one value. Okay, and 128 because we are giving 128 inputs, 128 outputs. Inputs are of the 32 size, and the output is of the 1 size. Okay, so we are going to, I think we already ran this. Yeah, so we have trained our model and we have saved our model as well. So let's see what we get. So we are getting this my model and the sample data. If we change to the my model, and then if we do the ls, we get these files. So these files are there, but this is on uh, the Google Collaboratory notebook server. So from there we cannot directly deploy it onto a Docker container. So that's why what we have to do is we have to copy it from the Google Collaboratory to our G drive. So we are going to mount the Google Drive, and then we are going to recursively copy, because see, there are multiple files here. So even this is a directory. Okay, variables is a directory, so that's why we copy it recursively from this particular directory to our Google Drive. And it could be anything, any directory that you can create. In my case, I have created that as a saved model. Okay, so I copy this from here, and then it will ask for the authorization code, etc. So I'm not going to get into this because I already have copied it earlier. So uh, this is how that saved model directory is going to look like. It has got this variables directory, it has got saved model.pb, etc, etc, right? So if I click on this, you can see that there's this variables.index file, and then the actual file where the variables for the trained model are saved. Okay, so that's pretty much about how we train the model on the Google Collaboratory and then copy it back to our Google Drive. Okay, now let's go to the next step. So next step is actually we will have to copy it onto the local drive from the Google Drive, and for that what we can do, there's a download command, right? So for example, this is a saved model directory, and if I click on this, I get this download here. So we can download this particular directory and then kind of unzip that directory, okay, on the local drive that we have, right? So once we have that, the next thing that we need is some kind of Docker engine that we can run on the operating system that we have. In my case, I had uh, the Windows operating system. So what I did is there is a open source product called as Docker Desktop. So I downloaded that and set it up on the Windows, and then I got I pulled a couple of these images from the uh, Docker repository, which is so this is a TensorFlow serving image actually. Okay, so we can pull this image from the Docker repository and get it into the Docker desktop, and then we can use this particular image to run a container for us. Okay, and let's try to see how we uh, run that particular command. So what we have to do is we just have to run this particular command, the docker run command, because we already have the image. So we have to run this particular command, and what we have to say is we want to use this particular image, TensorFlow Serving. We are giving same the name of the model that we have into our saved model directory, and then we are going to copy this you know the models and the variables to the container. So this is our local storage where we have stored the model, and this is the path where we want to save it onto the container. Okay, so for example, if I can copy this command, okay, I copied this particular command, and then I'm into this command prompt, and I'm going to run this. So we are running this now. Let's see what happens. Fantastic. So what happened, our container was loaded. So container was loaded, and then after that the model that we specified in the command, even that got loaded actually. And as you can see here, the it is already bound to 2 ports, 8500. So this is a local host, right? And 8500 port is for gRPC, and 8501 port is for the REST API, right? So our container is deployed now, and it is ready for accepting the prediction requests, right? So let's go and do some predictions also. So for that, what we are going to do is actually we are going to use the curl command, and we are going to use this particular JSON string here. And as you can see here, this particular data is like has got 32 values, because earlier we had seen that we have designed our model to accept a input vector of 32 values. So that's why we are giving these 32 values here, and this is the type of the request that we are sending. This is the URL of the deployed model that we have, right? So let's copy this, and let's also have another command prompt. So we have this, and we are going to send this request. So there you go. We got the prediction for the inputs that we provided, right? Because we had trained our model to give a single output value when we are having these 32 values as input, right? But does it actually change? Let's try to see. If we change the input data, the expectation is that we should have some change in the predicted value also, right? So let's see if that is actually happening or not. So let's make this as 1 and send a request. Did it change? So this was our earlier prediction, this is a new prediction, so it actually does work. Okay, so this is a Vertex AI dashboard. So Vertex AI is a Google Cloud Platform service, and this has been launched quite recently. Now, one of the options for creating the models in the Vertex AI is to import the TensorFlow pre-trained models. So we can train the models outside. So in our case, we have trained a model onto the Google Collaboratory, and then we copied it to a Google Drive. From there we downloaded, and from there we upload it into a GCP bucket, right? And we can go and import it from the GCP bucket using the import option. Okay, so we just have to give some model name to this model. This is the region has to be same as where we have saved our model into the bucket. So we can just click continue, and we have an option of either using the pre-built container or the custom container. And in the pre-built containers, we have scikit-learn, TensorFlow, XGBoost. So we are going to continue with the TensorFlow, and version so 2.5. Accelerator is whether we have trained the model on GPU or CPU, and this is the location of the model, right? So we are going to browse, and we are going to we have stored our model into this imported models bucket. So we are going to select that bucket. Okay, and then what we have to do is just click on the import, right? I'm not clicking on the import for now because I already have got our model imported. So I'm going to just use the already imported model here. So the next step is actually to add our model to an endpoint for the production purposes, right? Now endpoint is a logical kind of an entity where we get a URL for calling a model, so we can invoke the endpoint with a REST API. Okay, so let's see what we have when we click on this option. So we have to give some name to it. So I'm going to give so in this screen there are quite a few options here. So one of them is the traffic split. So traffic split is if you are doing multiple models, we can decide like how much traffic goes to each of those model. Another option that we have is we can auto scale our deployment. That means we can decide the minimum number of servers and the maximum number of servers, and it is going to basically go from minimum to maximum depending on the traffic that we are sending in, right? So say for example this could be something like 6, and the minimum could be something like 2 or 3 or whatever we want. Now when we are saying minimum, that means we are taking care of the fault tolerance. So we have a minimum number of servers which are already running, and the maximum number, so depending on the traffic, it will go from anywhere between 2 and 6. Okay, and we also have control over the type of the machine that we need to have, whether we can either we can select standard, high memory, high CPU. For now I'm just leaving it as standard. Okay, and after that we just say deploy, and the endpoint is going to get deployed, right? So isn't it very simple? What we did was we just trained our model, TensorFlow model, outside onto the Google Collaboratory, and then we uploaded it to a GCP bucket, and from there we can just import that model and then deploy it to an endpoint. And that endpoint we have the choice of setting up the auto scaling as well, and we also have the choice over the kind of the machines that we want to deploy our model onto, right? Now that's fantastic. And in my view and opinion, if you are really starting with the deployment of your TensorFlow models, this is really a good option, because from the deployment perspective there is practically nothing that you have to do. It's very straightforward, right? So that was all about the Vertex AI that I wanted to show. So this is also a option where you can see your deployed endpoints, you can do the batch prediction and couple of other things, but I'm not really getting into that for now. Okay, now let's come back to the summary, and let's recap what we did. So what we have done so far in this session is we have seen the different options for deploying and scaling TensorFlow train models. So option number 1, standalone server. So we deployed our model onto the Google Collaboratory notebook server, but you can deploy it onto any other server as well, including any virtual servers on AWS or GCP or Azure for that matter, or you can deploy it locally also. Second option, Docker containers. So and the Kubernetes on top of that. So we can use any Kubernetes engine on any cloud platform, or we can do a Kubernetes deployment locally also. And we also have the option of using the KubeFlow. So if you have multiple deep learning frameworks, if you want to deploy those onto multiple clouds, KubeFlow is a good option, right? So the first option is fully unmanaged, second option is semi, and the third one, Vertex AI, is a fully managed option that we have, right? So that's pretty much about the last session that we went through. Now to sum up the whole series, for that matter, TensorFlow Basics with Hemant, what we began was the minimal concepts like tensors, variables, eager execution, auto differentiation. Then we moved to modules and layers, and then we also learned about TensorBoard. We saw how to track the performance with Profiler. We also got to see the TensorFlow Dataset API, and later on we moved to the Keras API. So we spoke about sequential API, functional API, Keras built-in methods, and we took a look at various Keras layers, including pre-processing layers. And we also covered loss functions, optimizers, activations. In the last video we also discussed various ways to do distributed training, And finally, we have also discussed how to serve uh, our trained models in the fault tolerant and the scalable manner, and what are options for doing all that. So I sincerely hope that you will find these videos useful. If you have any comments, any thoughts, or any topics that you want me to make further videos, please let me know through your comments on the YouTube or on the LinkedIn. I thoroughly enjoyed making those videos, and I also thoroughly enjoyed sharing whatever I have been learning, and I'll continue doing that, and I'll be back with a new series